Another advantage of having a 3D model is the ability to do rebar detailing in 3D. This reinforcement is done even directly on the file or on a reference file, and even separating these different elements that we need to detail even to different operators, and then all together reference all that information to having a complete bridge detail. The advantage of doing this 3D detailing is not only on verifying conflicts, but the ability to do bar bending schedules, bill of materials, and not only even that, but sending that uh, rebar detailing and the schedules to the rebar cutting machines. Then from the 3D model, we can cut plan sheets, right, with the full detail that we need, incorporating materials, incorporating all the information needed with different views, not only the plan view, side view, section view, but also a 3D model itself. So how we do that, we're going to be learning that as well, in which all these elements are fully detailed in 3D. The tools available in the software are just designed to do all that kind of information and generate concrete quantities, generate rebar quantities. Well, and using this, even different detailing codes. Of course, the ACI is there, but if we're doing projects international, we can just use all other codes as well, British, Australian, so on and so forth, that are part of the solution. So we can use all of them and the way they call their bars, the way they are bending the bars, and the different nomenclature that is used to call the different elements of a bar detail. So get into different views, and we're gonna establish even the what is called the bar mark ID. So through the positioning option, we can just label each one of the bars fully automatic. And then each bar will have a unique ID depending on uh, bar shape, depending on position, depending on length, and so on. And all these options could be translated to uh, bill of materials, right? And these bill of materials could be formatted as the user may prefer. So as the bars have ID now, and we selected them, now it's being grouped, and this is the bill of materials. So before we used to do these rebar quantities all by hand, now it's fully automatic. And any changes in the model will trigger changes on the bar, and then we just need to rerun the quantities, being able to generate this fully automatic, even manipulate it if we need it after the fact, group it different ways, so accommodating to any design standard that we may want. Now, how we visualize our model, right? We have put it into the real world. So, for example, if we establish a coordinate system, right? Every state has, every part of the world has a reference to what they call a coordinate geographical system. So we can just need to know what is that geographical system depending on the state we're in, depending on what location of the state we're in. There are multiple states. There are states that have multiple coordinate systems, so we need to know that. And having our files with this reference system, so now we can access with a direct integration to Google 2D and Google 3D and place our design into the real world. So that is the integration with Google directly from the Bentley Open applications. Not only that, we can also integrate not only with Google, but with Google Earth. Again, the same using the coordinate systems. We can also coordinate with Google Earth, place our file there, so we can share that location to external users, so they don't need the open application or the Bentley open applications. I'm talking about Open Roads, Open Bridge in this case, but directly send them the KMZ file and see and visualize our design just in Google Earth. But now, if we want to achieve full collaboration, right? So then we can generate what is called a digital twin. In Bentley, it's called an iTwin. So our project, our design project, is connected to the cloud, to the Bentley infrastructure cloud, and the design that we're working up to the last minute. So it could be sent or generated automatically and placed into the cloud. Now, using our web browser, any user with the proper authorization can access that digital twin not only for the bridge, but even for the entire project with all the disciplines that are connected to it and review the project in real time. Now, if he has any observations, uh, so then all that comments or maybe errors that he discovered could be applied to the digital twin, and the platform will communicate that comments to the user that generated this particular twin. So there's terminology that we use. The bridge uses what is called a civil connector to basically translate the DGN information, the design information into a digital twin. Because remember, we're not only sending graphics, but we're sending the properties of the bridge. So the final user or the iTwin user will be able to see the materials, will be able to see all the geometry information that is stored into that BIM model, that physical model. Again, and not only, as you can see, not only seeing the bridge itself, but the entire project that is being generated from multiple users and all combined into a single element called the digital twin, and review what we have designed again up to the last minute, last hour, last day, or last week. Again, it all depends how often you want to generate this digital twin. Now, if we want to further share information, now it's embracing a software agnostic, meaning that there is no DGN, there is no DWG, there is IFC. So all our file with all its properties generates an IFC file. We're going to explain later what IFC is, but at the same, it generates a neutral software that with a free viewer, we can see our bridge and see how it's being generated, all the information that is inside, being able to archive that information or share the information with users that don't have the particular software solution that we're using. So this information is already, or the generation is already part of the software. So it's just a matter of just say, I want to generate an IFC file, right? Uh, But remember, this is not an interactive like an iTwin or a reference file. This is the generation of an external file that is able to compile all the properties inside my bridge. Of course, the graphical information as well. It has this IFC file has different versions, so we need to select what version, and it will generate the file for us. So this file will contain all that information, and we can share it externally to non-application users. They will need a viewer that is free in the market. There are different ones of them, Beam Vision or OpenIFC. So that's what I'm using right now. So I just load that IFC and I see all the properties. These files follow a specific structure, a specific wording that it needs to use to classify each element that is being studied by different DOTs. So it's a work in progress. Now, also taking advantage of the platform that we use to generate the bridge. The platform microstation, as I told you before, an open bridge is running on top. We are able to access or take advantage of this platform and generate outstanding graphics or even animations. So Lumen RT, it's a visualization application included inside the platform, inside MicroStation, and of course, Open Bridge, Open Roads, Open Tunnel, so we can generate all these amazing animations uh, to what I call sell the project to the general public. This is how it is going to look like. And if we combine this with aerial photography, aerial survey, we can see not just an animation, but then how our project is impacting the real world.